Hello everyone, myself Devashish Das, Assistant Professor of Electronics Communication Engineering Department of Greater Kolkata College of Engineering and Management. In this video, we are going to study about the different topics of analog electronics and its applications, how the analog electronics apply in our different fields of electronics. In this video we are going to study about it, different circuits and its part we are explaining one by one in this topic. Analog Electronics 1. This course is mainly for diploma students of electronics and telecommunication engineering of third semester. The paper code is PTCE AE1S3. Welcome to another session of my video lecture. In this session, we are going to discuss mainly on clipper and clamper circuit. So in this session, we are going to mainly discuss on what are the clipper and clamper circuit, what are the basic elements of this clipper and clamper circuits, what are their applications, what are the benefits and drawback of clipper and clamper circuits. So first discuss about the clipper circuit. These circuits are applications of PN junction diodes. The clipper circuits are used to clip off a portions of wave from an input signal. This is used in two ways, series and parallel. The clamper circuits clamp a signal to different DC level along with diodes, capacitor and resistors are also used. So these are the use of clipper and clamper circuits. So first discuss about the clipper circuit. The clipping circuit is a wave shaping circuit and is used to either remove or clip a portions of the applied wave in order to control the shape of the output waveform. One of the most basic clipping circuit is the half-wave rectifier. A half-wave rectifier clips either the negative half cycle of the or the positive half cycle of an alternating wave or the sinusoidal wave and allow to pass only one half of the cycle. The clipping circuits are also referred to as a voltage limiters, amplitude selectors or splicers. Clippers are used to eliminate amplitude noise or to fabricate new waveforms from an existing signals. So these are all about the clipper circuits. Now we are going to different types of clipper circuit. Clipper circuit can be classified according to non-linear devices which are being used of the circuit. It is the diode clipper and the transistor clippers. According to the biasing, that means the applications of the voltages or some power supplies, based biased clipper circuit and unbiased clipper circuit. In case of biased clipper circuits, some voltage source are being used, and in case of unbiased clipper circuits, there will be no voltage source used in the circuit. According to the level of clipping, the clipper circuits can be classified into three categories: positive clipper circuits, the negative clipper circuits, and the combinations clipper circuits. So according to the configuration used, the clipper circuits may be series diode clippers, parallel or shunt diode clipper, a series combinations of diode, resistor and reference supply, multi-diode clippers consisting of several diode resistors and reference voltages. According to the level of clippers, clipper may be classified positive clippers, negative clippers, biased clippers and combination clippers. There are two general categories of clippers: series and parallel or shunt. The series configuration is defined as one where diode is in series with load, while the shunt clipper has the diode in branch parallel to load. Thumb rule of the clipper circuit: this is the very important thing which we have to keep in mind to do any clipper circuit, and we have to understand the working principle of the clipper circuit. This thumb rule have to be kept in mind. According action of biasing on diode: when the diode is in forward bias, it acts as a closed switch or on state, or we can say the diode is in short circuit. And when the diode is in reverse bias, it acts as a open switch or a open circuit or a open state. So these two are the main important thing. We have to check the biasing of the diode, whether it is in forward bias or it is in reverse bias. If the diode is in forward bias, it acts like a on switch, or it is closed, or it is a closed circuit or short circuit. And when the diode is in reverse bias, it is the open circuit or open switch. So diode clipper overview: the basic components required for a clipping circuits are an ideal diode and a resistor. In order to fix the clipping level of the desired amount, a DC battery must be introduced. When the diode is in forward bias, it acts as a closed switch, and when it is in reverse bias, it acts as a open switch. Different levels of clipping can be obtained by varying the amount of voltage of the battery and also interchanging the positions of the diode and the resistor. Depending on the features of the diode, the positive or negative region of the input signal is clipped off, and accordingly the diode clips may be positive or negative clippers. So first come the series clipper circuit. First introduced as a half wave rectifier for sinusoidal waveforms. However, there are no boundaries on the type of the signals that can be applied to the clipper. In a series positive clipper, the diode is connected in series with the output in forward bias. The series negative clipper, the diode is connected in series with the output in reverse bias. In series bias clipper, a battery is connected with the resistance. So first come a positive series clipper circuit. So now we'll understand what is the things going on in case of a clipper circuit. So it is a positive clipper circuit. It has only one diode and a resistance. The P side of the diode is connected to the resistance, and at the node of this P side of the diode and the resistance we take the output. And in the Vin, in the point AB, a sinusoidal input wave is applied. So we have to check the polarity and the biasing of the diode in this circuit. So when the voltage increase slowly, the A is positive and B is negative, we can see the positive potential is applied to the inside of the diode and a negative potential is applied towards the P side of the diode through this resistance. So the diode is in reverse bias state. When the diode is in reverse bias state, the diode did not conduct, it's act as a open circuit and there will be no current flow through this circuit. When there is no current flow through the circuit, we get a zero potential output at the output voltage. So when the positive peak is there, there will be no current flow and we get a zero output at the output state. In case of the negative peak of the input signal, when it is negative and B is positive, at that time A is negative, that means it is connected towards the inside of the diode and the positive section is connected to the P side of the diode with the resistance. So now the diode is in forward bias state. When the diode is in forward bias state, the diode allow to flow the current through this resistance and we can get a same polarity, almost V in at the output. There will be a little voltage drop, but the voltage at the output is almost same in phase as the resistance circuit is there, and we get a negative clip output or the negative. So it is the positive clipper. Positive means we can get the same output as the input. So it is the positive clipper example of the circuit. So here you can see a negative clipper. Negative clipper means it is the positive clipper. Here the positive peaks are clipped out. That means the positive waveforms are removed from the input signals and produce a negative waveform in the output. That is why it is the positive clipper, as the positive portion of the signals are being clipped out and it is removed the positive signals. So it is the positive clipper. Now comes the negative clipper. The name suggested, then we can see at the output signal first the negative portion of the input signals are clipped out or it is removed. So it is a negative clipper. Now we will just see the working principle of the negative clipper. It is a diode. So when there is a positive voltage is there, for case of the positive peak, the diode is in forward bias and it's allowed to current flow through the resistance and we can get the output voltage at the output. So in this way, in case of the forward peak we can get the output, but in case of the negative peak, when it is in the reverse bias condition, when it is negative and it is positive, so in case of the reverse bias condition, this diode is in reverse bias state and did not allow to flow the current. It acts as an open circuit, so there will be no current flow and we cannot get any output at the output. So in this way, it is the working principle of the negative clipper circuit. So here you can see, in case of the reverse bias, you can see it is the open circuit, so the whole voltage apply the E is across the diode, so the diode voltage is E, and there will be no potential drop across the resistance, so there will be no current flow. Here you can see the mathematical analysis of the reverse bias of the diode clipper circuit. These two are this picture is showing the biased clipper, positive clipper. These two are the positive clipper circuit, biased positive clipper circuit, series positive clipper with bias, and this is a bias series negative clipper. Here you can see a positive portion is being clipped out, adding of this voltage source, just add a voltage level and make a positive portion clip of the signal, input signal. And similarly, in case of this circuit, it is also a clipped out of the positive signal of the input signal and produces the positive clip output. All things are happen the biasing of the diode. When the diode is in forward bias, the diode allow to flow the current through this path, and when the diode is in reverse bias, there will be no current flowing through it, only we can get the voltage potential of this battery or the voltage source across this Vout terminal. So in this way, the same phenomena happen. If you analyze carefully, you will get a negative clipper. All the negative portions will be clipped out for this circuit, and for this circuit you will just get these portions of clipping out of this circuit. So these two are the example of bias clipping circuit. The bias means additions of voltage sources inside the circuitry, so we get a voltage level in the clipped waveform, either positive clipper or the negative clipper, and we get the waveform according to the voltage level and the positions of the diode. Now comes the parallel clipper circuits, also known as the shunt clipper. The output is in parallel with the diode and the resistance, which are in turns in series. Like series, there is also positive and negative shunt clipper. Like series, we have bias parallel circuits with adding of connecting batteries with the diodes. So let us see the parallel clipping circuits. So these are the parallel or shunt positive clipper circuits. The positive means the positive portions of the input signals are clipped out, or it's removed from the input signals and produce only the negative portions of the output. In this case, we have applied the input signal to Vin. When the voltage rises up, that means it is the positive and it is the negative portions, and the diode is in forward bias. And when the diode is in forward bias, it acts as a short circuit, and as for a ideal diode, it's just a conductor and it's make a short circuit, and there will be no potential drop across a short circuit. That is why we cannot get any output in case of the positive peak of the diode, positive peak of the input signal across the diode. In case of the negative peak of the signals across the diode act as a reverse bias state, and at that time the diode act as a open circuit, or it is in reverse bias. So the whole potential of the input signal is dropped across this diode, and we can get a full deflection of reverse or the negative peak across the diode, and we can get the negative peak of the input signal at the output. So in this way we can get the positive clipper circuit with the help of this parallel or shunt circuit. So there is a shunt or parallel circuit with negative clipper. The negative clipper means, we just to keep in mind that the negative portions of the input signals are moved off, or it is removed and is clipped off, and when we apply a positive potential of this input signal, in the first the diode act as a reverse bias, it is positive and it is negative. So the diode is in reverse bias state, and we can get the positive peak like previous picture, which we get in the reverse negative peak, and in this way we get a positive peak. So it is the example of a shunt negative clipper circuit. Let's some mathematical expression of these parallel configurations. Here in this case we have two diodes which is connected in parallel circuit. Each diode has a cut-in voltage of 0.7 volt. So the two diode has the same cut-in voltage, so it is of 0.7 volt. As the diode is in forward bias, so for a practical diode we can get a 0.7 volt of output voltage. As the two diode is in forward bias, we just get the voltage drop across this forward bias of the diode, and which is for a practical diode it is 0.7 volt. So VO is 0.7 volt, and we have applied a 10 volt power supply over there. A battery of 10 volt is applied, so we get the 10 volt minus 0.7 volt, that is across 9.3 volt across this resistance. It is the 9.3 volt, which is the voltage drop across the arc. So we can find the current across through the arc. It is IR equal to 10 volt minus 0.7 volt divided by 0.33 kilo ohm. It is the resistance of the amount of the resistance, so we can get 28 milliampere of current through this resistance. So in this way we can get the current, and this total current flowing through the resistance is divided into these two diodes. So the each diode is flowing of current 28 divided by 2 equals to 14 milliamperes of current. So you can find out that the each diode is flowing 14 milliampere of current through it. So it is a mathematical expression how we can find the currents and voltages of the output and through the diodes. So in this type of problems may come in your exam. So in this figure we just see the two types of clippers. One is bias shunt positive clippers, another is bias shunt negative clippers. Positive clippers means the positive portions of the input signals are clipped out, and in case of the negative clipper, the negative portions of the signals are clipped out or removed from the input signals, and we just get a the bias means there is a additions of voltage sources, and due to these voltage sources the operations are pretty much same. If the diode is in forward bias, there will be no voltage drop across this diode. If the diode is in reverse bias, the whole potential difference will be across the diode, and accordingly, and due to the incorporation of the DC voltage source, there will be a voltage level clipping for both the positive and the negative clipper bias. It is a shunt type clippers, and we can get this type of clipping waveform at the output. All the inputs are sinusoidal wave and they are of same frequency, and we get a output like this. So now come to the summary of the clipper circuits. There are different types of clipper depending on the positions and the bias applications of the voltage sources. So we can get different combinations of the output signals of the same input signals depending on the positions and the biasing of the diode. We can get a different types of clipping circuit. They are parallel clipper, and these are the series clipper. So these two types of clipper circuits are mainly used to get our desired waveform, and we can shape the output as our requirement to the input signal. So this is all about the clipper circuit. So now come to the applications of the clipper circuit. The clippers find a wide applications in televisions receiver for separating synchronizing signals from composite picture signals, and also in television transmitter at the time of processing the picture signals. So these are the all applications of clipper circuits. Clipper are also employed for different wave generations such as trapezoidal, square or rectangular waves. So just you can find it out the applications of the clipper circuits. We're not going to read it out for now. Now the drawbacks of the series and shunt diode clippers. In series clippers, when the diode is off positions, there will be no transmissions of input signal to the output. But in case of the high frequency signals, transmission occur through the diode capacitance, which is undesirable. This is the drawbacks of using diodes as a series element in such a clippers. In shunt clipper, when the diode is in off conditions, the transmissions of input signal should take place to the output, but in case of the high frequency, the input signals, the diode capacitance affect the circuit's operation adversely, and the signals get amplitude, and this is not desired for the proper operation. Now comes to the clamping circuit. Clamping circuit we have discussed in the very beginning of this session. A diode and a capacitor can be used combined to clamp a AC signal to a specific DC level, or we just change the value of the DC level. If we understand this clamping circuit, this is the input signal which is applied in the Vin. It's a square wave containing two peaks, V positive, V negative. In the first cases, when it is the positive, so diode is in forward bias and its conduct, and for that there will be no output is present. and when it is in reverse bias, the combination of this potential and the potential across the capacitance which is stored previously for this cases, combination of these two potential provides the twice the voltage in the output. So in the first half cycle of the input signal, the capacitor charge up to the potential V when the diode is in forward bias. In the next half, when the diode is in reverse bias, this potential V and the previously stored capacitor value, the potential V, combination of these two V produce 2V output at the output. So in this way, the clamping circuit changed the DC level of a signal from one stage to another. So some notes: the start the analysis of clamping network by considering the part of the input signals that will follow forward bias the diode. During the period the diode is on state, assume that the capacitor will charge up instantaneously to the voltage level determined by the network. Assume that during the period of when the diode is in off state, the capacitor will hold on its established voltage level. Keep in mind the general rules that the total swing of the total output is swing of the input signals. So basic clamper circuits we have seen in this picture. The input signals can be any type of waveform such as sine wave, square wave or triangular wave. The DC source lets you adjust the DC clamping level. Here this is a bias clamper circuit. We can find a battery over there or a voltage source is applied. Depending on this voltage source, the level of the signal gets changed. And in this way a bias clamper circuits work. Now come to the summary of the clamper circuits. There are various types of clamper circuits available. So we can see some of the clamper circuits and the output of the clamper circuits depending on the biasing positions of the diode and the input of the signals. So now come to the applications of the clamper circuits. The complex transmitter and the receiver circuits of the television clamper is used as a basic bias line stabilizer to define the selection of the luminance signals of the presence level. The clamper are also called as a direct current resistors as they clamp the wave from to a fixed DC potential. So you can find out what are the applications of the clamper circuits. Clampers can be used for removing the distortions, for improving the overdrive recovery time. Clampers can be used as a voltage doubler or voltage multiplier. These are the all applications of the clamper circuit. So that's for today. Thank you for watching. If you have any queries, you can contact to me. The contact number is given. The same number can be used as WhatsApp number. If you have any queries or doubt, you can call me or WhatsApp me to this number. Thank you very much.